Hi, I'm Toli. By day, I work in games, and by night, I spend my time tinkering. I've worked on a bunch of miscellaneous things over the last couple of years, but one of them really stood out. Oh, the cursor in the middle of everything? Okay. One of them really stood out for me, and I'm happy to talk about any of the others. And it's this question mark block I built. One of my group of my friends was having a 16-bit party, and I was asked by one of the DJs to make a punchable question mark block. I'd been talking with Metal about buttons, and this is basically a giant button. At the place I was freelancing, they had an old 4:3 screen, and so I took the principles of a button, built out a simple prototype, laser cut some wood, and made a little 4x4 version. Now it wasn't without peril. I tried laser cutting some wood that the glue just heated up and sealed it back down again. That didn't work out. But after a bit of experimentation, I found the right thickness and type of plywood, and a few trips to Home Depot later, I had a laser cut box. It was all masked out, properly done, and I spent some time spray painting it and painting it up so that it actually resembled a Mario question mark block. When I was working on this project, I picked out a series of kick drum switches for the base of the box. So you could punch it as hard as you want. You can kick it. You can do whatever you want to it. It's made out of plywood and kick drum switches, so it will take that, and hopefully it'll register. I tossed in a bunch of diodes on top of the switches so that they wouldn't go the wrong way to the Pi, but probably was unnecessary if I'd done my wiring right. Here's a little shot of the inside of the box. The screen's all mounted in with bolts, buttons on the bottom, and then a Pi up on the top. It's all fed power by this extension cable, and there's a USB hub embedded in the roof so that you can toss on a keyboard or mouse if you need to do some quick editing, which definitely happened a bit. And over there you can see it all pressed together with wood glue so that it actually stays in one piece when it's punched a bit. So here it is, all assembled and running Raspbian, and wow, it works, it's great. We've got some of this all was put together rather through Pygame. I had a bus trip from San Francisco back down. Okay, how do I render an image, make it respond to an event from a Pi, and boom, we've got a sprite on the screen. So it works, it's wonderful, it's great. But unfortunately, when you punched it, because I had a delay to my code, because the Pi kept displaying the thermal warning on the screen, and I turned that off, but I figured that since it was displaying a warning, I should probably fix it. I had it all set up at this event, and you could punch it, but there was a 100 millisecond delay on the code to just keep it from overheating. If you didn't punch it at just the right moment, it didn't register at all. So after the event was over, I took some time to research how do you make buttons stay on slightly longer, because I didn't want to fix my code. And I ended up running across the 505 chip and coming up with an analog solution. I got an oscilloscope from Utah and from my girlfriend's grandfather, and ended up making a rough prototype monostable chip that you click the button and it stays on slightly too long, so a little bit of basic analog electronics. And then I took it a step further. Rather than just putting this wonderful bit of wiring into the box and being like, that probably will work forever, I jumped into KiCad and with a bit of help from Metal learned how to actually make a little circuit board, and got that put together and figured out that this is a second revision actually. The first one, I didn't break out the right pins, so the circuit worked, but you couldn't pull anything out of it. And this one allows you to press the button, have the power running through it, and then take a data pin out, and it stays on for however long you put a resistor on there. So here it is working at the party. You can see I punch it very slowly because it has to stay on for 100 milliseconds, otherwise it won't register. And if you would like to take a punch at it, it's over there in the corner. Feel free to punch it, kick it, whatever. It stays on for about 5 seconds, and then it'll reset. So you can take a quick picture if you're so inclined. And that is my project.
Why does it need to stay on for 100 milliseconds?
So when I was coding it, I noticed that the Raspberry Pi started to heat up quite a bit, and it started displaying a thermal warning on the screen.
Do you know why?
Well, I had a while loop in Pygame, and it basically was maxing out the processor. And so I put a sleep in for 100 milliseconds, because like, that seems like it'll just fix the overheating issue, and it did. But it meant that it was only picking up inputs from the pin every 100 milliseconds. And so if it wasn't on right as it was trying to sense, because I made a mistake while coding, it wouldn't pick it up at all. So rather than fix that, I made an analog solution, which is not the right way to do it, but I had time. I wasn't under a time constraint for the solution because it was sort of working for the event.
So is this video before the analog solution?
Yeah, this is before the analog solution. Yeah, I could probably rearrange the slides and be like, it works, actually, and dive deeper. But I feel like this is just kind of a fun thing to sit on. But, yeah. Any other questions?
Do you know what the solution would be if you were to try to fix it in software only?
Probably break out the sensing from Pygame and have it just update the screen when you actually get an input, rather than having it run a full game loop and try to run sensing inside the same loop, because that was excessive. Yeah. Okay. Thank you, guys.